Wait a second. I'm not sure. I cannot hear you guys. Let me check. Let me check why I cannot hear you. I can see the transcript. I can see there is non-fundo that was saying something, but I couldn't hear you. Sorry, non-fundo, can you please repeat again? Yes, like can you repeat again?
Can you hear me now?
Yes, yes, I can hear you.
Oh, I was just saying HADPU stands for, or HDFS stands for HADPU distribution file system.
Yes, that's correct. All right. So
may I add, sir?
sorry, anybody else talking?
Saying may I add on to what she said?
Okay.
So she said it's a file system designed to store and manage large data sets across multiple machines.
Yes. Thanks for the details. So so basically your HDFS is the we're dealing with the Hadoop, which is just a framework that will help us to manage the data. Because remember now, when we're going to mix, when we're going to mix, what you call this cloud computing, we're going to mix AI and big data. So basically, remember when we create tools, maybe you create an AI system, you have your data that you're going to manage with cloud computing technologies. And then you're also going to use cloud computing. So cloud will deal with how data can be managed or how data can be saved or stored outside of your local computer, which will be in some sort of cloud. Okay, so the three technologies will work together. Okay. All right. So, guys, can you guys still see my screen? I'm not sure. Can you still see the content, the page that say content?
Yes.
Okay. Thank you very much. Okay. So basically, as I said, the Hadoop is just the HDFS stands for Hadoop Distributed File System. So this system is just to help us. So, I don't know if you've heard about a company called Apache, Apache. Okay. So Apache is a company. So for them, they are just based on storing data, dealing with data. So there is um, many companies use them actually. So when you look at companies like TikTok do not store the data themselves. So even TikTok is still using those services. Okay, even TikTok is still using those services. All right. So we spoke about namespace yesterday. So we mentioned namespace. Name node, so basically the name node will manage what we've called the metadata. Remember, I told you yesterday the metadata will be the address that will actually tell us where the file is. So basically, it contains the file name, the directory where the file is, which is like the folder, and then we have the so basically it show you the location of that. Okay, so that is the name node, and then we have now the data node. So data node will actually store the actual data, which is actually the actual data block. So wherever those data are stored, they're going to be stored into the data node. Okay, so I hope you get that. The main difference between the name node and the data node. Okay, so the name node will store the metadata, and then the data node will store the file content. So that is very important. Okay, so we have many key features of the HDFS. And remember, we also mentioned yesterday that's the HDFS. So basically, when we're saving data in the HDFS, they are saved into blocks, right? So this is what we have. So we have different blocks, right? Which will save different data. So basically the way the blocks are split based on the data. So the default size for that will be around 128 megabytes to or 256 megabytes, which will be saved into this blocks, right? So each blocks will be, if I can say, replicated across multiple data nodes. Okay, so we will have that. Okay, and then every node that we have. So the client, okay. So the client here. So we're gonna go the client, which is the actually the user. So we have the file name or the data block that is saved as a name block, right? So the name block will get the location, right? So let's say, for example, we want to write a file. So a file wants to be saved. So basically, the client will gets the block location, and then the data is written. So basically, we go from client, gets the name, the location, and then the data is stored in that location. So now that's a file or that data is in this location, and the name code, the name node is as already saved what's the location, so we can always access that. Now, if you want to read the file, that means when we want to read the file, when we run the commands to read the file, when we run the command to read the file, what it's going to do is it's going to look for the name code. Remember, the name code. What was the name code? What is the address of that data? So it's gonna get the list of all the data stored there, and then it gets the actual data that we're looking for. And this whole process is done using HDFS. So this is kind of the architecture of the HDFS. So as you understand here, we have different racks, we have different location of the data. And the data can be, we can add new data, or we can read the previous data. So there's many key features of that, right? So you understand that when we have the HDFS, it contains namespace. It contains namespace that contain directory, files, and blocks. So this is the name codes, right? Which will contain where the name of the directory, the files, and the block where it is, right? So, and then you need to remember that, okay? So, another thing that is very important. So, what is the client? So, the client is the most commonly used method for users to operate HDFS. So basically, the client is the part of the system that will help you read and write into the HDFS platform. Okay, so basically, the client is a library that contains HDFS file system interface, and it hides most of the complexity of the HDFS implementation itself. So basically, the client is the part that will help you handle this. So we can call it, we can just say it like the user interface of the system. It's like the part of the HDFS system that help you manage that. Okay. So as I already said, so the client will help you with operations such as opening files, reading files, or writing files. Okay. Okay. All right. So you also need to note that the HDFS, it also provides what we call Java API. So an API is just an API can be a certain portion of code that help you connect to a different system. So an example I can give you is you're creating an app and you want to use a map. So you can request what we call a Google API. A Google API, Google can give you a small code with a key that help you connect to the Google system just to import and use that small system of the map. So now in this case, HDFS, which is the Hadoop platform, the Hadoop distributed file system, can also provide some Java APIs. Okay, so basically you are using Java APIs as client programming interface. So if you are busy coding in Java, or you are busy creating some apps, you are using that, the platform can give you access to that. Okay, so it's very important to note that there's also some disadvantages of the HDFS single name code. Okay, so the problem in HDFS is that you have when you have only one name code, when you only set one name code in HDFS, the issue that you're going to have, you're going to have some limitations, right? You're going to have some limitation because you have only one name code set for that. So the namespace limitation that you're going to have is that the number of objects or files or blocks that you have. So you have many data there. Remember, we have different type of blocks that keep different information. So now when you have when you have the one namespace, one name code, which means that everything that you are getting is going to be saved in that one name. So you now have an issue of the space. So this is an example that you have. So let's say you have something like this. You only have one name code there. That means all the data that you're going to get, everything is being saved in the same place, which creates a namespace issue, right? So it's very important maybe to have multiple name code. So, and then you have the performance, you have isolation, and then we're gonna go more into details about this and see how they affecting the system. Okay, and some of the limitation as well that you can have is that when you're running such a big program, you're running such a big program, and then you have an issue with all these namespace, it becomes a problem because sometimes you're going to have an issue, but you don't know where was the problem. Okay, you don't know where was the problem, where is the issue, but actually the problem is in the namespace limitation. But we're going to talk more about that, and we're going to really dive deep into it when we do it practically. Okay, so these are some key features. You will have Zookeeper, which we're going to talk more about. Okay. All right. Okay, so when you're dealing with data, remember last time we mentioned the fact that when you're dealing with data, it's very important to note that the data that you're dealing with they are safe and they are secure, they are being used properly. Because remember, let's say you're dealing with a system of an hospital. If you're dealing with a system of an hospital, you're dealing with people's medical record. So dealing with people's medical record is a very challenging area, because now you have all these laws that try to protect people's privacy. If you're dealing with medical record and you are careless about them, or your data are not secure, that becomes a problem. I think I've watched a movie where there was a story of a company that was providing artificial art. So basically, for people who have a heart problem, they will basically get an electronic heart. But the company was controlling, they were monitoring, they had a system to monitor everybody's heart to make sure all the clients were fine. So if there's any problem with your heart, because the artificial heart, they can easily call you and do a maintenance of the heart. And now there was a time where there was an hacker would just access the system of the company and start requiring money, because he will choose to turn off people's heart and start killing people like that. So now when you look at, you have a business like that, you have a company like that, your data need to really be secure, So the security of the data become now a big issue, because this is people's lives that we're talking about. So when we're dealing with data in HDFAs, we need to also look at the integrity. So basically, we need to ensure that every component that we're using is actually making our data secure, and everything is secure. Our data are controlled properly. Okay, so this is very important. We need to make sure that every system, the architecture we're using, the way we're handling our data, everything is just secure. Okay. All right. So these are certain commands which you're going to use when we do it practically. So you're going to see that where we're going to be using certain command in our terminal of our coding platforms. So when you're using HDFAs, so certain command that you write will do certain tasks. For example, you have the cat, call it cat, C-A-T. This one will just display the file content. So if you're looking for a file content, we have a dash cat that will display the file content. So basically, guys, what can happen is that in your written exam on big data, so you're going to have a portion of the exam that talk about the lab part of the exam, which has a lot of marks as well. I think maybe tomorrow we'll try and see how we'll try and see how the marks are distributed, because you will have the theory part and the lab part. So in the lab part, you can have question on things like that, where you have maybe a multiple type of question, where they tell you, for example, in HTFS, the CAT command will, and then they give you options. Maybe option 1 can be display the file content. Option 2, print the content. They can give you those 4 options there. So it's very important to know what are these commands and what do they do. So, okay. So you have the CAT command, which will display the file content. You have the ls command, which display the list. And then you have the rm, which deletes a file. So when you look at this command apply in many programming language. Even when you're dealing with servers on your website, let's say you have a web app that is dealing with a server, and then you have to access it through the terminal and delete a file or edit a file. So most of these commands will kind of be the same. For example, you have the ls. The ls will display the directory, to display every file in that folder. For example, every folder in your data code. Okay, so you have the rm, which deletes a file. You have the put, which will upload the directory or file to. So basically, if you want to upload a new file or directory, you're gonna use this command, the put command, and then you have the get command, the mkdir, which creates a directory. So all these commands here will help you do whatever you want to do, whatever task you want to do in the system. Okay. Any questions so far? Any question on anything? Are we still on the same page? Are we still on the same page? No question. Okay, so basically, if I can, I don't know if there's a way I can write here. So we're gonna have something like that. For example, I am dealing with, I want to find a list of all the documents, all the directories. So let's say, for example, you have a folder called medical record, another folder called maybe medical history, or maybe if you are dealing with a system in the university, maybe there's a file where you're keeping maybe students maybe math tests. Another one is maybe physics test, right? So, and everything, all the directories are on your HDFS system. So if I want to see all the directory and make sure I've created everything, so there's a command I will do in my in the system, which is this command here. So I'm gonna do HDFS, DFS, and then /SL. So this command here will show me the list of um, all the files, all the directories. Okay, so let's say I want to upload a directory. Okay, so if I want to upload this, I want to upload a directory, which is a folder. Let's say a folder on my computer or on any system, and that folder is called maybe data. That's where there's my data. So I can easily go on the terminal of the HDFS, and then I'm going to write HDFS, DFS, put. And then this is the file name. And then I put it in what directory? In the directory called data. As you can see here, this one is to upload. Okay, so these are example of how this can be done. Okay. So that's what it means. So these are just commands that you use. Okay, so when you look at some new features that you have with the HDFS, the new version, the HDFS 3.0, you can have something like the EC code, okay, and then you have the union based on HDFS router, and then you also have multiple name nodes. Remember what we say about one single name node. There's a challenge, there is a limitation of space, there is different challenges. So this problem can be solved with the new version of HDFS 3.0. Okay. Okay, so this is the HDFS data read write process. So when you want to read, to write, remember we're reading if the files already exist, we're writing if they don't exist. So you can create new files and delete new files. Okay, guys. So when we start doing the practicals of this, We will know all these processes. We will know when we're dealing with name node, what are name node, data node, what is data node. Can anybody tell me, in your understanding, the main difference between a name node and a data node? Anyone? Anyone?
So many.
What's the main difference between a name node and a data node? Name node and data node, what's the main difference?
So if I'm not incorrect, right? So I think the name node, it's the path to where the actual data node is, and then the data node is just the data itself or the file itself.
Okay, yes. I didn't hear you properly. I don't know. Can you maybe repeat? What's the difference between a name node and a data node in big data, in HDFS system?
I was saying the name node is the path to, it's the path, right, to where you can actually find a specific data node that you're looking for. And a data node, it's the actual data itself.
Okay, yeah. That's a good answer. That's a good answer. So basically, when we're talking about the name node, so the name node is just going to be um, the link. So it's basically kind of a link or a path to the file. So we'll have the directory, the block, the file name. So that will be part of the name node. But when we're talking about the data node, is the actual data. So the actual content of the file. Okay, so that's a good answer then. Yeah, so remember now we have the HDFS client, which is the part of the system, the part of the framework that help us handle this data. So when we're using that, right? So I am going to try and see if I can get a picture of how it's look. Yeah, looks like I'm not getting the right picture, but it's fine. Okay, so now when we look at that now, so when you have your HDFS client, so this HDFS client is your user interface, basically. Okay, so when you have that, and then you create a file request that you create. So basically, it depends on what you want to do. Do you want to write a file, or do you want to read the file? So let's say you want to create a file request. You want to create a file. So now, when you're looking at the system now, the first thing that it's going to do, it needs to create a file metadata. A file metadata means it needs to create a path to that. So basically, the file can be maybe the name of your system slash what you call this. So you have the file name. Maybe the file name is student marks. So you will have maybe student marks. In the file data, there must be the directory. Maybe the student marks are in a directory called university. Okay. And then it gives you the block location. So where in the HDFS system, this is going to be saved to the block location. And then you can have something like the permission. The permission can be maybe you want to have this file or this folders protected. with maybe a password or something like that. Okay, so basically the name code must come with that. So the name code needs to keep that information. Okay, so the name code will actually manage what we call the namespace. So the whole space that will be there, it's gonna be managed. That. Okay, but you need to know that the name code does not actually store the actual data. It only stores the information about the data. Okay, I hope you understand that. It only stores the information, which means in what directory it is, what's the permission, what's the file name. That's what the name code will save. Okay. So now from that information, when we created the file metadata, which means it's the name of that file, we've created that, then it can write the data. So when it writes the data, we need to write the data and save it in what? In the data node. So the data node is gonna save the data. The data node actually saves the actual data. Okay, so now there can be multiple data nodes. So multiple data nodes in a cluster. So this whole thing is called a cluster. So this we're dealing with this file. So in this cluster, there's multiple data nodes, but there's usually a single name node. So a single space to save all the name nodes. And remember, we spoke about it being a challenge because sometimes there's a few limitation with that. But we've mentioned that with the HDFS 3.0, it gives you an option to have multiple name nodes. Right. So what we can say about the name node, we can even call it a metadata manager. So it manages this metadata. Metadata is that's address and whatever. And then the data node can be considered to be the actual data storage. All right, guys. So after we write the elements in the data node, so the next step we need to understand that this this data node always sends some periodic reports. So it always acknowledge to the name node about the presence of this data node. This will help in terms of reading the data. So when the name node is being searched, the data node as well, this name node is linked to certain data. So you have a name node there, you have a metadata or a file with an address stored in the name node, and this file must be linked to a file that is present in the storage. Okay, so you have the data node which acknowledge to the FS data output stream, and then from there you can close the file. So this file has been written. Okay. So any question? Any question on how to write on the right process? Any question? Okay. There's no question. Okay, this is how you write. And then we have the read process. So the read process, remember now, in this time now, we already have the file in the data, right? We already have the file in the data. So now what we're going to do here? What we do here now is that when we're using the HDFS client, if we request to read the file, remember now we already have those commands to read the file and everything. So when we run that command, what the program does is it goes into the name node and find the information about that file. Okay, so it finds the information about that file. So it read the request. We're requesting a certain file, okay, and that's from the FS data input stream. It's going to read the data from the data node. So we can read from any data node. And from there, we already have the content of that data. We can do whatever we want to do with it in our program. All right, guys. I think that's all about the HDFAs. Tomorrow we're going to start with Zookeeper. Okay. All right. Any question? Any question before we can call it a day? Any question, guys? Any comment? Is there anyone still challenged by the registration? And I can see other people have registered on AI and they're writing to me to say the application is still pending. Guys, make sure you register for big data first. Make sure you are registered for big data because now I'm only approving big data so far. So please make sure. All right, guys. If there is no questions, I think we can just take a screenshot of the class. You can just turn on your camera so we can just take a register, a screenshot register.